Hi, this is your teacher, Adam Billman, and once again I'm here to just give you a brief overview of something that I had basically started teaching you, but I'm going to finish teaching you now. Every single test that we've been doing can be done simply in a calculator. You'll see over here we have a TI-84 plus color edition, very similar to the standard version. If you press Stat and go over to tests, you'll notice that the first two tests that you see here are the z-test and t-test, and the next two after that are the two samples z and t tests and the two proportions t and z tests. This makes up every test that you have ever had to do. The big ones being the standard t-test, which would be a test of means, a one-sample proportion t-test, and of course our two-sample z and t tests based on whether they're a proportion or a z. Going into a single one of them, if you go to a one-sample test, you will notice that you have two options. You can either A, go look at data, or directly into stats. For most of the questions on the AP, you'll probably be using this section. Here you can list what your mean is, what your x bar is, that is to say what the measured mean is, and any standard deviation you found. So, for example, suppose you wanted to find out whether or not this number happened to be significantly different from 12, and your x bar was 30, let's say just 30 straight up, and your standard deviation as measured was, let's say, 4. You might ask the question, okay, given that we did this all with a sample of, let's say, 25, is it indeed the case that there's a difference? So, since I'm just interested in the difference, I select the two tail test, not the one tail, but the two tail test. Go to calculate, press enter, and lo and behold, it'll do all the calculations for me. It'll determine whether or not indeed it happens to be true or not. In this case, it's saying that it's not true. The t-test has a t-value of 22.5 and a p-value of 1.2717, and other statistics should I need any of those. Going back to our tests, we can of course perform the same thing but with a one proportion z-test. Very similar, except here you'll notice there is no option for data. None of the proportion tests will have an option for data. Instead, but we still have the same basic idea. We have to list what our null hypothesis is. Let's say 20%. And we then determine how many successes we have, which goes in x, how many total we had found, whether or not we're doing a two-tailed or one-tailed test. And when we got all this information in, we press calculate, and lo and behold, once again, it will do all of our stuff for us, calculating the z-score, the p-value, and the sample p-value, which is clearly higher than 20%, being 28%. Now, let's go ahead and make sure we see at least one example of how you could go ahead and perform a test with data. And we're going to do this with a two-sample t-test. So if I go into here, once again, I ask for stats and data. I will select data this time. And having selected data, it wants me to go ahead and input data into L1 and L2. So I'm going to have to obviously make alterations to those particular lists first. But where am I getting this data, of course? And the answer is pretty simple. From Excel. I've already gathered all the data. I happen to have two different lists. The only thing I have to do here is I need to order all of my data so that I can find it as such. And in fact, I go over here, I can tell it to sort. We'll tell it to sort by whether or not they graduated, but the idea being that we have people who graduated high school, people who did not, and what they earned annually. And we can then sort by that, giving me the lists here, which I can then input into the calculator. So let's first go back into Stat, Edit, because I need to edit my lists. We'll clear these lists of all of their data. And having done so, I shall input all of the no's in first. I have 10 of them, and then all of the yeses, going one by one. So that'd be 3, 4, 9, 1, 7, 25637 42634 35976 35083 37902 33217 36806 27 876, and finally 31702. These are my no's, and putting in my yeses, I can do the same thing, just with the higher numbers. 50297, 55532, 53428, 59947, 61090, 53446, 55832, 57232, 52480, and 50938. Once all the numbers are placed in, I can go back to stat, go back to tests, go back to my 2 sample t-test, press enter. And then from here, I can simply tell it I'm going to test list 1 against list 2. I'm going to once again do a simple, actually let's go ahead and do a one-tailed test. Let's make this a little bit different. I want to say that mean 1, which would be the no's, since that's what I put into list 1, is less than mean 2. So I'm trying to say mean 1 is less than mean 2. Go back over here to calculate, press enter, and lo and behold, it did all of the math for me. I have a t-value of negative 10.822, p-value that's basically 0, 3.2 times 10 to the negative 9. Degrees of freedom are listed here along with my 2 means and their 2 standard deviations. So this is how you can perform all of the tests using a calculator instead of doing it by hand. Remember, you must still describe, according to steps 5 and 6, the t-value and the p-value, and you must list these. If you do not list them, you will lose credit. But aside from that, you should also list your degrees of freedom, which will be listed as well. With all of this said, I am going to go ahead and call this one done. I hope all of you guys have a wonderful time and enjoy your day.